Hi kids. We have a problem here. It's a component problem for Newton's laws, and it says Joe pulls a 35 kilogram block with a force of 120 newtons at 30 degrees above the horizontal. The coefficient of friction between the block and the ground is 0.22. And it asks us, what is the normal force and what is the acceleration of the block? So let's take a look here. We want to always start out with a picture, P. So I have a block on the ground, and I have Joe pulling it with a force of 120 newtons at an angle that is 30 degrees above the horizontal. We always have the force acting due to gravity. So as you can see right now, I am making my free body diagram. There is a normal force between the ground and the block. I'll dub it Fn. And we have to check to see if there is friction in the problem. And since there is a coefficient of friction, there will be a force due to friction that opposes the direction of motion that Joe is working for. Fantastic. Now it says, what is the normal force? In order to find the normal force, we need to find out what is the F net in the y direction. Because in the y direction, that is where the normal force exists. Now, in the problem, we have to see, is the block actually accelerating in the y direction? And because the block is only traveling horizontally in this problem, it will not be accelerating in the y direction. And so if F net is equal to m times a net in the y, and if the net acceleration in the y direction is 0, that means that F net in the y is 0. Because of that, the sum of all the forces in the y direction is also going to be 0. So if I add up Fn plus the force of gravity, Fg, plus the force applied in the y direction, and I would call that just F sub y, all of that should be equal to 0. Now if I wanted to take a look at all my knowns, my unknown first would be the normal force. My knowns, I happen to have the mass is 35 kilograms, and I also know that the acceleration due to gravity is 9.8. So 35 times the negative 9.8. And I get negative 343. Now that negative sign indicates to us that it is going to be pointing downwards. So since I do have it as a picture here, I am going to have it that it is a negative 343. So F sub g is equal to negative 343 newtons. All right, that's our first known. The second thing that we need to know is F in the y direction. But unfortunately, we were only given that it was 120 newtons at 30 degrees above the horizontal. So what we need to do is to break this force vector into its components, x and y. To find what it is in the y, I just have to do a little bit of trigonometry. 120 times the sine of 30 gives me 60. So I know that F in the y is a positive 60. Be careful with your signs. You want to make sure if it's pointed up, it's positive. If it's pointed down, it's negative. So now that just leaves me with unknown, known, and known is equal to 0. So I could go ahead and plug these values in. I have that Fn plus the force due to gravity, which is negative 343 newtons, plus the force in the y direction, which is a positive 60. All of that should be equal to 0. If I go ahead and solve it by bringing these to the other side, and I solve it for Fn, I get that the normal force is a positive 283. Fn is a positive 283 newtons. That means it is pointed upwards, and that positive does also is indicated in our picture up here. Bye, kids. Hi, kids. In the previous problem, we found that the normal force was 283 newtons, and that was pointed upwards. For part B, it says, what is the acceleration of the block? In order to find the acceleration of the block in the horizontal direction, that means we are looking for F net in the x. And that is equal to m times a in the x. So if our unknown, what we are looking for is this acceleration in the x direction, we need to know the mass, which was given to us. So mass was equal to 35 kilograms. And we need to know what F net in the x is. F net in the x is not only m times a, but it is also the sum of all the forces in the x direction. Now because of that, we need to take into account all of the forces in the x direction. And it looks like we have a component of what Joe is pulling and the force of friction. So we have the force due to friction plus the force applied in the x direction, and that will equal m times a in the x. That will equal what our F net is. So we need to know what is the force of friction, what is the force applied in the x, and the mass, and we should be able to figure out what the acceleration in the x direction is. So let's start with the force in the x, since that is one of our unknowns. We were given that it was 120 newtons pulled at an angle of 30 degrees above the horizontal. So doing a little bit of trig, we should be able to find that component there. 120 times the cosine of 30 gives us 103.9. Let's put it down as 104 newtons. And so F in the x is going to be 104 newtons. Now, to find the force of friction, it was not given to us directly in here. It is not 0.22. In fact, in the problem, it only gave us that the coefficient of friction was 0.22. So how is that related to the force of friction? Well, we remember that the force of friction is equal to mu, the coefficient of friction, times the normal force. So thankfully, we found out what the normal force was in the previous problem. It was 283. So if I go ahead and replace the normal force with 283 newtons, and I replace the coefficient of friction that was given to us as 0.22, I should be able to calculate straight out what the force of friction is. 283 times 0.22 is 62.26 newtons. So now I have the force of friction, which was 62.3 newtons. I have the force in the x direction. I have the mass. And now I could go ahead and solve for the acceleration in the x direction. Solving for this, I get, one thing I forgot. Shame on me. Look in the x direction. I have that as 104 newtons, and that is pointed to the right. One thing I forgot was to indicate which way was positive. I have that up was positive, and I also have that to the right is positive. But look at my force of friction. I have that is 62.3 newtons. It is pointed in the opposite direction, so that should have been negative 62.3 newtons. So, putting that into my equation here, I have negative 62.3 newtons plus the force in the x direction, which was a positive 104 newtons, is equal to 35 kilograms times the acceleration, and that is what we're looking for. Solving for this, I get an acceleration of 1.2. Acceleration in the x is 1.2 meters per second squared. And that's it. Bye, kids.